In this lab, we're going to apply our sub-pixel tracking skills to characterize the performance of a high-end piezoelectric actuator, or a piezo. We will compare the performance of the piezo both in open loop and in closed loop mode. Piezos can be used to translate objects and position them with a resolution of less than a nanometer. But this excellent resolution comes at a price of a fairly short range of motion. The piezo that we will use can travel only up to 12 microns. Obviously, to inspect such small displacements, we will need a microscope. We will use an upright reflected light microscope and visualize the piezo motion with the help of our familiar microscale. We simply put the scale onto the moving part of the piezo, where we can hold it in place with a small magnet. The reflected light image of the microscale looks like this. Now let's use the piezo to move the microscale. First, we would like to achieve a strictly linear bidirectional motion. In other words, we want the scale to move left and right at a constant speed that is the same in both directions. We should be able to do this with the help of a waveform generator that supplies a triangular voltage waveform to the amplifier that controls the piezo. To the eye, the motion looks fine, but how accurate is it really? And how does operating the piezo in open and closed loop affect its performance? We can answer such questions simply by tracking and analyzing the motion of the microscale. To simplify tracking, we define a small region of interest that contains only a single bright bar. The vertically averaged horizontal intensity profile of this region contains a strong peak that corresponds to this bar. I am using custom-written software to track an intensity maximum. I'm defining the range of pixels surrounding the peak to which a parabola or a cubic will be fit. Here I'm choosing a third-order polynomial. The program will calculate the maximum of the fitting curve and save the result. The overlaid yellow curve shows the result of the polynomial fit as the program analyzes the recorded video frame by frame. Now, this approach may not work so well when the image does not contain a prominent isolated feature. In such cases, we define a small search box around the most suitable feature and update the position of this box after each search cycle. Here, we center it around the most recently found position of the intensity maximum. Note that the program only displays the part of the intensity profile that lies inside the search box. Finally, let's have a look at the results. Our sub-pixel tracking algorithm is capable of resolving well-known differences between the piezo responses in open loop versus closed loop operation.